Okay, I have applied 12 volt power to the signal processing board and measured the voltage across the power pins of the op amp, pins 4 and 11, and I see 12 volts. So that indicates that the op amp is probably okay. Okay, I have wired up the signal processing board in the test configuration. What I've done is I've supplied the board with 12 volt power. I've connected a variable current source. It's a variable voltage source set up as a adjustable current source, and that goes into this input here and comes out over here. Let's see if I can find my finger here. And the current sense resistor in particular is over here. That voltage developed across the current sense resistor is processed by this operational amplifier chip here. The signal is taken out of this terminal and input into a scope probe, and I'm watching the signal on the scope. The time base is 2 milliseconds. I have 1 volt per division. There appears to be some kind of noise flutter on the voltage, which I have not seen before. It might be part of the problem or related to the damage that occurred when I ran the double-sided test. I will now increase the current flowing through the current sense resistor, and we should see a corresponding increase in this output voltage. For every amp of current, I should see 1 volt of signal voltage. Start from 0, and should be at about an amp. It's a little bit more than an amp due to some errors. Okay, there's an amp. I'll do this quickly since there's a lot of current flowing and the wires will get hot. There's 2 amps. There's 3 amps. There's 4 amps, and 4.5 is the maximum that the supply can handle. Okay, I'll now ramp it back down, and the wires are probably pretty hot right now. So that concludes the test of this side. I will now test the other side. Okay, as before, I've transferred the injected current to the other side, and now I'm operating on the lower current sense resistor. It's the voltage developed across that current sense resistor is processed by the op, and I moved the scope probe over to the other output of the op amp, and I will watch that output on the scope. As before, the time base is 2 milliseconds, 1 volt per division. And I also see some fluttering on the output voltage, which I don't remember seeing before, but it is also present on the other channel, so it might be part of the test setup that's causing this quote-unquote noise. I will now increase the current flowing through the current sense resistor and watch a corresponding increase in the output voltage. Again, it is 1 volt per amp approximately. Okay, as I increase the current knob, obviously, no current flows, but the voltage increases. So therein lies the problem that indicates to me a short circuit. An open circuit, because current is commanded to flow. There's nowhere to flow, and the voltage correspondingly rises, trying to push that current, but it can't. Therefore, the current shown is 0 and the voltage rises. So I believe I found a broken connection. I will now go hunt it, correct it, and retest.